Hello everybody. Welcome to ALife and Art keynote panel discussion. The focus will be today on generative AI and sound music. My name is Masako Shiva. As Alyssa just mentioned, I'm co-founder of Brooklyn Experimental Art Foundation. I'm also director for the art program for ALife 2025, and I am honored to integrate brilliant artists' works and their presence into this conference, which is one of the most exciting things that are happening right now. I'm so thrilled to be here. First, I would like to extend my sincere thanks to the amazing organizing team at ALife conference, including, of course, our speaker, Dr. Ikegami, and Cross Labs, Olaf and Alyssa and Jean and her daughter and everybody in between. And also congratulations to ALife Institute for opening. Really a lot of amazing things are happening around the space of ALife. And I am so excited to see the thriving community here gathered today as we celebrate in the name of art. As I said, we have amazing artists that are working in the field of not just artificial intelligence and ALife, but the concept of integrating technology into their practices. And we have prominent artists, Lu Yang, Schlumper is here today as well. Schlumper especially, he's giving sound activations every morning at 8:30 at 4i. Next to his installation. So it's a really fitting way to start the conference every day. So I hope you have a chance to see this. And Alyssa was so generous by mentioning how I am hosting this, but I'm merely moderating. And the people who actually did put this together is Keisuke-san and Yutaka-san. So they deserve all the credit for preparing the grounds for this rich conversation we're about to have today. So I'm going to explain a little bit about how this works. I'm going to introduce the names of these brilliant speakers who do not need introductions to begin with, but I'm going to say their names and what they are here for today in this panel. And I'm going to invite them to give presentations, short presentations here, and it will be followed by a free-flow conversation and Q&A, all ending in about an hour, like noon-ish. So I'm very excited to have these brilliant minds here today. And I'm going to start with Dr. Takashi Ikegami. Ikegami sensei from Ikegami Lab, University of Tokyo. He is the true pioneer of ALife and such a trailblazing figure. I know I promise I'm not going to go into details of introductions, but I can't help but say that. And he will be presenting today his iconic Scary Beauty performance that took place in 2018 ALife, and a little bit about Bert Chan's Linnea and broader reflections on art and artificial life and the lineage of it. And we have Professor Tatsuya Daikoku, Next Gen AI Research Center, University of Tokyo, presenting the developing brain and the evolving music from the perspective of human-like intelligence. Now, that already sounds so interesting, and I'm very excited about this. Dr. Nao Tokui, artist, founder of Qosmo New Tone. He will talk about his experience in generative art, generative AI and music performance that he actually does. And Dr. Fernando Rosas, University of Sussex, a multidisciplinary researcher with an eclectic background in music and music composition, philosophy, pure mathematics, and electrical engineering. In this session, he will be speaking about our current understanding of how music works from a complexity science perspective. So this is all really exciting conversations that are going to be taking place by diverse backgrounds of these brilliant scholars and leading researchers. And I am thrilled to first invite Dr. Ikegami to the stage to present his practice.
Yeah, can you? Well, okay, I'm gonna stop here. Can I? So 2018, I organized the Artificial Life Conference. Then, as a premiere of this Android, I played the day before this ALife, Artificial Life Conference at the same venue. I did it. This Android is, as you see, the conducting orchestra. The orchestra is 40 students from Kokuritsu Music University. So, so I thought, conductor is more like, just periodic something, right? But it's not, because I don't know so much about the classic. So it's not a metronome, right? So I thought it's a metronome, but when I repeated rehearsal many times, then the players get familiar with the Android, and this one, the Android is called Alta. Then first of all, they never look up the Android because it's so weird, and so their conducting was so aperiodic, so they cannot play with this one. But gradually, they like to look up the Android, and then also take a selfie together, getting very much a friend with each other. Then but before the rehearsal, the rehearsal was sometimes very bad, right? They didn't make any good music, but only this day, I have to say, was very successful, and it's so nice. And then I was really, also I was very much stimulated and impressed that maybe using this Android, that we can make artificial life. Artificial life to me is creating, not just mimicking existing living systems. It's more like creating a new life, new forms of life, new emotional structures, new way of thinking. So I think it's very the first step, that maybe using art can also help us to understand what is the essence for artificial life to study. So it's just the beginning, but this is and then also it's the first time that I introduced art section into this ALife conference. And then Brad-chan submitted linear to this art session. So when I saw linear, and I said, wow, what this one is, But he submitted as an art piece, not the science article. But then of course, immediately I tried to told him that you should submit this one as a new form of the gliders, or using chemical reactions. And then maybe I didn't bring the movie here, but of course you guys know about what the linear is. So that's the beginning of how the art is integrating with the science. I think science sessions. Then also this Android is actually, I have to explain that. Air compressing on 43 degrees of freedom is controlled by the program, but now that we are using a large language model to control this Alta 3. But I talked too much yesterday about this one, so not today. But then I think that this is the beginning of how art is integrating with science. Then today's the speakers also interested in how to use a generative way of making music, or understanding music, or try to understand art using this strategy and tools and concept that we developed in artificial life. So, okay, so it's my turn. Thank you.
Amazing. Thank you so much, Dr. Ikegami. That was the iconic presentation of Scary Beauty. I also want to note that there's Ryuta Oki-san over there who has been involved in that year's presentation of, I just wanted to acknowledge him over there. He has been very instrumental in ALife.
Can I explain one thing?
Yes, please.
Also, this music is composed by my very good friend Keiichiro Shibuya, and he's an artist. He's a composer, and then he's now in Paris and Tokyo. But after that, he's making a lot of Android opera, so that maybe you can see them in Europe and then also in Tokyo on the 5th of November that we're going to have a new one. And also Itsuki Doi over there, that he main programmer of this Android when we did Scary Beauty.
Wonderful. Thank you so much. Truly integrated into art and the science experimentation in a way that reaches so much more than before. Maybe Daikoku Sensei, if you want to present next. Thank you.
It's okay. Thank you very much. I'm usually the one who end up saving the time for all to speak, but today it's changing. And Professor Ikegami-san's talk was so grand in the scope that I'm a bit intimidating for me to present after him, but I try to the best. So I'm a basically music neuroscientist, and this is actually my first time at ALife. I don't know this culture at all, but to talk here, I was thinking of the relationship between music neuroscience and cognitive science and artificial life. And my view is that music is a lifelike embodied code that self-organizes through collective prediction and cultural transmission. We don't need to learn musical rule. Just by being exposed to sounds around us, our brain starts predicting, anticipating what comes next. And these predictions are shared across people, across time, across culture, forming something like a field intelligence. For example, based on my neural finding of implicit learning, which contribute to brain development, sorry. I lose, okay. I built a music predictive model using a logical possible code progression. The model learns predict pattern simply by exposing no theory, no rule, just by listening. In other words, without any rule-based learning, we humans seem to share certain pattern of collective prediction, a kind of unspoken agreement that engage simply from hearing the sound of the world. Just like a billion of the cells in our body, each one independent, each one unaware of the others, and yet together forming the living organism we call a human being. Music may also arise as a kind of living organism emerging from the countless interaction among us humans. So let's listen to a few short examples, each with for musical code by controlling how uncertainty and prediction error change over time. First, all four chords are low in uncertainty and prediction error. It feels very expected and predictable. Okay. It's not interesting. Well, but my predictive implicit learning model. Okay. I present twice again. They generate the very predictable one. But second one, interesting from this, the first three are the same, but the prediction error of the fourth chord is high, but uncertainty is still low. That means a clear surprise. If that didn't sound surprising, you might not have grown up on the earth, or at least not in the pop music culture, right? Now, third one. The third chord raises uncertainty. You are not sure what's coming. But when the first arrives, you feel, I wasn't completely sure, uncertain, but yes, that's what I expected. How is that? In the third chord, it's difficult to predict, but fourth chord, probably predictable. Maybe you can understand that one. So further, here is, so even without explicit learning, humans predict music implicitly. By controlling the temporal dynamics of prediction error and uncertainty, we can shape emotion like reassurance, curiosity, anxiety, even beauty. Further, here is something else we found fascinating. After hearing these code sequences, I asked people, where in your body did you feel it without using the language of emotion? This was a body map study with 500 participants. They simply reported subjective body sensation without language of emotion. The result was fascinating. A predictable music was felt in the stomach, while the clear prediction error was felt in the heart. That much embodied expression like my heart jumped, or in Japanese, hara ochisuru or funi ochiru, it's settled in the gut or gut feeling. And the stronger the heart or stomach sensation, the stronger the people rate the beauty. This means the embodied feeling is the core sense of beauty. So finally, let's move to the collective field intelligence. I analyze such temporal dynamics of prediction error and uncertainty in hundreds of jazz improvisation from 1900 to 2000. Lot of the jazz improvisation corpus data. Each point in the plot shows one music pieces. Black for older and white for newer. What we found is that musicians from the same era share remarkably similar fluctuation pattern without intentionally designing them. Style evolved as if guided by field knowledge, collective knowledge, a kind of designing without a. That's what I mean by a lifelike embodied code that self-organized through collective intelligence. Music as an example of artificial life unfolding in sound and body. Thank you very much. Sorry, lastly, it's already the time, but this is my dream, my future direction of the research. If we visualize such a temporal dynamics in each era, from the Renaissance to now, we can actually see how music style evolves, and by extending the pattern into the future, we can even compose near-futuristic music. I actually tried this, but today it's already time. If you want to hear, please come find me. Thank you very much.
Thank you. That's incredible. We have to come find you so we could hear more of the where the music is going to affect us. Yes. Yeah. Probably not our stomachs. more in our heart.
Yes, body, yeah. Without language.
Yeah, there you go. Thank you so much. And continuing the theme of feeling music in your hearts, Dr. Tokui, who has been using generative AI as a method and a concept that invigorates his practice as a musician and a scholar. Thank you.
Good morning. This is the ALife project I've been working on right now. Good morning, everyone. My name is Nao Tokui. I'm an artist and AI researcher, and I've been seeking new ways to use AI for music making and performing. And I write about AI and creativity sometimes. I also run a small company, two companies, and we are a small team based in Tokyo. And we develop AI technology behind popular music softwares for DJs and musicians. And we also develop trainable AI plugins, such as real-time timbre transfer or tone morphing plugin. And actually, I'm not so familiar with ongoing discourse in ALife community, but I'm so excited to be here because I started my journey when I saw Carl Sims' groundbreaking work in 1997. I was 21. And as in his comment here, I have always dreamt of making a system that makes music I can't even explain how it's made within the system. Inspired by Sims, I published my first academic paper in 2000. It was an interactive music composition system using genetic algorithms and genetic programming, and I trained tiny neural network for fitness function. And actually, I made a few tracks using the system by myself, and with a guy named Seba Jun. He's now known as Nujabes. Maybe some of you may be familiar with. And fast forward to 2015, I started using deep learning model in my performance. So this is AI DJ project, which is a back-to-back DJ session with me and an AI DJ system. Can you hear some? But the sound doesn't matter that much. So the here, because it's just a DJ set. So the AI selects music, or records, I should say, based on what I play. Yeah, in this case, my friend is playing. But so also I made a custom turntable and train a small reinforcement running model to match the beat of the record by changing the tempo of music. And it's not about automating DJ set. It's about exploring new way to perform as a DJ. And I was so fortunate to perform in front of 15,000 people. That's nerve-wracking, but and this is the sound is. So in 2022, the performance Yeah, so I used a few, I think it was 6 or 7 GAN models, generative adversarial models on stage. So I can create loops on the fly, and as a DJ, I mix them together to perform. And so everything you heard here was all AI generated in real time. And I also do live improvisation with musicians such as Big Yuki, New York-based keyboard player. So he played piano and bass synthesizer, and the rest is all improvised by me. So with AI, I can perform in a way I never imagined before, but I haven't yet reached my goal of creating a system that makes music we don't know yet. I don't know yet. So that's my current research topic and like a project I've been pursuing as an artist. And I don't have any solution so far, but I'm the reason why I'm here is to get some new insights from ALife community. But anyway, this is a tiny experiment I did in 2021 or 2020. So this is again rhythm generation model using GAN model. So I trained the GAN model on various MIDI dataset so that of course I can generate various rhythm patterns. Oh. Oh. Sounds boring, right? And so I added, I extended the GAN framework and added additional discriminator to classify the genre of generated rhythm pattern. Then the generator was trained to confuse the discriminator as well, so that it can generate rhythm patterns that are realistic enough, but also don't belong to any genres in the training data set. Then the output became much more interesting, in my opinion. Okay, so my question is how we can use computational system to create something new instead of just mimicking existing statistical patterns in training data. So I'd like to keep working on along this line to create music we don't know with the help of AI or maybe ALife. Thank you.
Thank you. That was incredible. So Dr. Rosas.
Great. So I'm Fernando. I work in the UK, and typically when I go to conferences, I present myself as a scientist doing information theory, complexity, computational neuroscience. But I'm very excited to be in this panel because I'm also a musician. And today I want to share with you some ideas I have about music, how it works. And to start this, let me present sort of the standard theory that is following very much what was presented before. So the idea is that the brain is a machine that is there to help us survive. And survival has to do with predictions. And predictions work with Bayes, right? So optimal probabilistic processing. So from this sort of very simple line of reasoning, we come with the idea that the brain is a machine that is all the time doing predictions and doing stuff like that. So from this perspective, music would be something about balancing the right amount of predictability and unpredictability. So if you have a sequence of events that are very predictable, that's not music, that's boring, right? And if we have a sequence of events that is completely unpredictable, that's also not music, it's noise. So what is interesting in music is that you have a pattern and you start predicting it and suddenly it's broken. And it's like, whoa, what is happening? And then there is a new regularity and then it's broken again. So it's all about playing with the predictability and unpredictability. And there is a notion of criticality that what could bring here. So music is at the edge between order and chaos and stuff like that. So this is sort of the standard view. And I think it's correct and super interesting, but I don't think it's enough. And I think my presentation today is to push the idea that ALife has some ideas that can be complementing this view. The first thing that I think is missing from this perspective is synergy. So synergy is something that I usually give talks of 1 hour. What is synergy? But let me compress it. So synergy is when a set has connections in the whole that cannot be seen in the parts. Here, this is a geometric example of synergy. So we have 3 rings. And if with your imagination you take one of the 3 out of the picture, the other 2 are not connected anymore. Right? And you can take any of the 3 and the other 2 are not connected. But the 3 of them are connected. So there is a triple connection that cannot be explained as a combination of pairwise connections. So it's a combination, it's something in the whole that is not in the parts. And we have done studies with this idea studying music. For example, we took the music of Johann Sebastian Bach. These are all the chorales. Here there are 4 people singing at the same time. And the intuition is that there is something, like when they sing together, they are doing more than the sum of the parts, right? So what we did is to compute some statistics. And long story short, it so happens that if you, for example, if I know that the bass is singing F, and I want to know what the soprano is singing, it's almost impossible. So the predictability from one voice to another is very low. But if I know what the bass and the tenor and the alto is singing, I know almost for sure what the other person is singing. So there is a nonlinear ability of prediction, or to think it in a different way, 2 voices are very weakly coupled, but the 4 of them are very strongly coupled. And what we saw comparing the music of Bach and Corelli, these are 2 composers from the Baroque period, so more or less the same, we saw that in Bach, all of them are synergistic in the sense of by knowing 1, you cannot tell anything about any other, but by knowing 3, you know almost for sure the 4th. In the case of Corelli, that was not the case. In the case of Corelli, if you know the viola, you know the cello for sure. And the reason is, this is cheating, because the pieces of Corelli that we study were written for 3 pieces. And then, because of the tradition of the period, the bass instruments do the bass with small deviations. So they are redundant. Basically, you can take the viola out of the concert hall, it's the same music. So in Bach, Bach wanted the 4 to contribute with something unique. And statistically, that's not very hard. You put random notes, all of them are contributing with something, right? But that's not very interesting. So synergy is when everybody's contributing, but nonetheless, the whole thing has harmony. And that's the take home from Synergy. Synergy allows local autonomy and global cohesion. And this is something that I think in music is very important, and this is not about this predictability story, it's something else. We have done similar studies with voice, and well, anyway, the thing, we have these three types of voice. In one case, super rigid, in the other extreme, completely free to do whatever they want. In the middle, some sort of balance. And what we can see is that in the case of the left, the question is if the center of mass is having some more information than the parts. And in the case of the left, like if you ask each of the birds where the center of mass is going, everybody knows. And the center of mass also knows, so there is nothing in the whole that is not in the parts. In the case of the extreme right, nobody knows anything, so there is nothing interesting happening. But in the middle, there is a balance where the flock knows where it's going, but none of the birds know where it's going. So it's sort of the same story. There is something that happens in the whole that cannot be reduced to the parts. And we can compute that, but that doesn't matter for this talk. I have been involved in a number of research where the idea is to see what difference make the whole versus the parts. From one perspective for the performers, so if you're performing in a group, and if there are little elements of improvisation that surprise the other members of the group because you are following the script but not so tightly, what happens then? So we have done studies on what is the impact on the brainwaves of the musicians, the brainwaves of the audience, the behavior of everyone, and that makes a huge difference. So the idea is that if you're all playing together the same thing and everybody knows what is happening, it's a bit more boring. There is less connection between the performers. But when some performer does something funny, it's like, oh, I was not expecting that, and then there is a whole social dynamic on stage that makes a huge difference. That's in the stage side of things. Also, we have done some studies on what difference make if you are listening the music alone versus in a group like here. And there is a whole phenomenon of synchrony that happens between the people that are listening together. So it also makes a difference for the listeners to be in a group. So all of these whole versus parts are sitting as being part of arts, and that has to be combined with the previous prediction story. Now, I think there is another element that is about agency. So the idea here, this is not my idea, this I heard from Philip Ball, a great British writer. So the idea here is the following. Where agents need to survive, survival requires prediction, and the key part of the environment that you need to predict is other agents, right? So that's sort of the dangerous bit of the environment. So evolution gave us this the agency detectors. We are naturally finding agents everywhere. We're always looking for them. And the thing is that when I think about arts, I think a lot about the distinction between circus and arts. What makes arts with capital A different from circus? Circus is impressive, right? We go to circus, it's, wow, this is incredible. But you see the trick again, and it's less incredible. So it runs out. Arts is different. You can read the book of James Joyce, and every time you read it, you get something new. So it feels that it's an infinite source of information. And the other thing, you read it once, that's it. And my conjecture is that there is something about agency behind that thing. So whenever we perceive that there is an agency behind the object, we go for it and we feel compelled to connect with it. When we feel that, let's imagine we have some artificially generated music, it has the right balance of unpredictability, whatever, but I experience that there is no agency behind that, I will not be so interested. So I feel that feeling agency in the artistic object is key in order to generate the connection that we feel with art. So as a summary, we have the standard view how music works, that is about this criticality attunement, so the right degree of predictability and unpredictability. I think that view is probably correct, but certainly incomplete. So we need more in order to give proper account of the musical experience. And I think ALife has some of the key missing parts, and there is a lot to win to put them there and to acknowledge them and integrate them. And that's it. Thank you very much.
Thank you. Thank you so much, Dr. Rosas. So I have just been told that we actually don't have too much time, so I might have to cut the Q&A, and don't hate me, but it's okay. Alyssa's sorry as well, don't hate her, she's trying her best. But these were all such exciting ways of thinking about sound and what that means. And in terms of generative AI, sound is just a vibration of air. And some would be words, and it will have meaning, and it will have additional emotions attached to it. Some will be music, what we call music, because of the maybe patterns or predictability, but we're talking about unpredictableness as an important element. And Ikegami Sensei's project was called Scary Beauty. The element of unexpectedness, the unknown is always scary, in my opinion. I hate bugs because I don't know how they move. But scary is a very interesting concept. And to bring that into music and to move people because you don't know what's going to happen, you don't know how you feel about it, is also very interesting for me from an art perspective. And what is exciting about how you are implementing generative AI into this is a whole new level of how we experience sound, I think. And it's also interesting because you're all talking about how you want to make music or sound that you've never heard before and you don't know how to express, but we're going to use words that are sounds to express that. So it's a very conceptually interesting idea that we're playing with here. So from all four of you, with very different approaches of how you interact with, perceive, and your interests and background of sound and music, I would want to have you talk a little bit more about, elaborate more about you did the presentation, but after maybe hearing your presentations, where your mind is in terms of what interested you most. Or maybe because you talked about what you have been doing previously, if there's more recent approaches that is exciting for you. Maybe Dr. Rosas, because you just came back from the conference of modeling consciousness, and that led you to this conference today, like a few days ago. Can you speak a little bit about how you are interested in the integration of this concept in ALife?
For me personally, my interest is a lot on art therapy. And I personally find it fascinating, the possibility of improving health, mental health particularly with arts. And I see a lot of that happening, but in a very ad hoc way. So people try things, sometimes they work, sometimes they don't. And I would be very excited to try to make that a bit more scientific, more systematic, in a way that can be implemented large scale in public services and stuff like that. And I feel that for that we need science. And I think that, as I said, like the key missing pieces are here. So that's my interest, to try to formalize conjectures about what might be those missing pieces, do experiments, and see if they work, and then if they are really making a difference for people, then they can be scaled up and implemented.
Amazing, amazing. And Daikoku Sensei, because you look at it from how humans interact with that unpredictability, and you talked about in the stomach and your heart, what do you expect for music that you do not expect in the super future that is going to come out? How would we humans interact with that?
Interact with the prediction. Interact with what?
We respond to that.
Well, it's a pretty difficult question. I was not thinking during your presentation, but at least I was thinking by hearing everyone's talk. Basically, music neuroscientists always focus on individual brain. So I think this is problematic. There's no music neuroscientist here? Okay. I'm a bit scary. But I was always thinking that more field intelligence or interaction in the music space is very important. That's why, as you say, your slide 3, this is my supervisor in Max Planck Institute. Everyone sees the individual brain, but I intentionally didn't say the brain. I say human to appeal the interaction of human between us and interaction between body. So this is my intention, and then I was expected to artificial life culture, because life is always there's interaction in the life, living organism. So this is my what I was thinking.
Amazing. And Tokui sensei also, you integrate brainwaves, I thought, in the past projects. And is there something about like the human condition and the brainwaves that you like? You're very like talking about multidisciplinary practices. You are all over you, and then you really bring it into music as an experience and as a performer as well. Like Nujabes and Big Yuki, those are people that I have on my phone that I listen to. It's like, so it's very interesting for me. How do you perceive that?
I think I'm just lazy. I mean, I want to have a computational system that composes music for me, with me. And I want to make music. So I started making music when I was 21, and I didn't have any musical background, and I don't play any musical instrument. So but I wanted to create interesting music or original music. And yeah, that's why I started using AI. But nowadays, it feels like AI is becoming more and more like technology of reproduction, right? You can copy and create some kind of variation, or you can mix existing songs in kind of interesting way to create new song. Like look at Suno or Udio, and these are amazing tools for consumption of music. But I don't. I want something else that I can use, or my artist friends can use to create new, unique music. That's why I'm so curious about the concept of open-endedness here in ALife.
It's very exciting, and I feel like that's a very artist perspective. I know this is a room full of scientists and scholars, but from art, as an artist, you come up with an idea and you present it in a form, and you actually, one of the important things about making art is that you want to see yourself how you feel after making the art. You want to interact with your thoughts externally. So what Tokui sensei is doing is such an artist perspective, which is very exciting. And Ikegami sensei, we need to allocate like 5 more hours to you to talk about this, because you see it and has such expertise from all different angles of how the lineage of how sound and generative art has come to be, and with your projects with so many collaborators that are the best in the field. And can you speak a little bit about what your thoughts are recently?
Okay. Yeah. Thank you so much. I'm very interested in the concept of agency. The people are studying agency, but until now I don't know whether agency was something to do with music. But Fernando just said that agency is necessary. And then I used to go to see rakugo. It's a sitting monologue comedy in Japan, which is very interesting, right? But then, there are 2 different kinds of rakugo. One is he's very good at, speaking and telling stories, but it's not interesting, right? But some of the rakugo players, his speaking is not so good, and then, but he's very much like fluctuating. But his rakugo is so interesting. And what's the difference is? I think the difference is because the latter one has a world view. So you can call it agency, but he cannot just telling the script, but he has the world view of what he's in, now, what the story is behind. He didn't tell the history or the world, environment, but that's reflected in his speaking, right? So in terms of music, I think John Cage is different. He has a world view, right? So what he's doing, he's creating his time timbre. I mean, something like there is no tempo or something, but you can play from yesterday to the 100 years from now, or something like that. So he's inventing so many different types of tools with his way of how he sees the world, right? But some of the music is very superficial. I mean, like using just sliders and making music, but it's interesting, right? Because it's lacking the worldview. So you can call it agency. So how to implement agency is very important, I think. Try to make not just computer as a tool to make music, but it's like there is an agency in it. That's why we can collaborate with program to make music. So that's something that I'm very much expecting in the future, and that's why I'm making Android. Yeah, thank you.
Amazing. And I am so sorry that we are going to have to, time is a concept, but it's very real right now still in this time, this era that we live in. So we are going to have to end this wonderful conversation right here. But please give it up for the wonderful panelists.